Welcome to this explainer. Today, we're diving straight into a massive, honestly mind-bending paradox regarding global wealth and our planet. Have you ever wondered if humanity is just doomed to destroy the Earth as we get richer? It's a huge question, and it sits right at the very core of modern development. I mean, think about it. We naturally assume that economic growth, industrialization, and consuming more resources, that all of that inevitably means more pollution, right? And irreversible ecological damage. But there's this fascinating, highly debated economic theory that suggests the exact opposite might eventually happen. So today, we're going to look at the data and the models to see if wealth could actually be the cure for pollution. All right, let's jump right into Section 1, the Growth Environment Paradox, which leads us straight into Section 2, the Environmental Kuznets Curve. Okay, so what exactly is this curve? It's formally known as the Environmental Kuznets Curve, or EKC. It was proposed by economists Grossman and Kruger back in 1991, and it gets its name from Simon Kuznets, who originally modeled income inequality. The core hypothesis here is incredibly provocative. It basically says that environmental deterioration rises in the early phases of economic development, but only up until a specific income level is achieved. In short, the theory posits that things literally have to get worse before they can get better. The concept takes the shape of an inverted U. Picture this. As per capita income grows, pollution climbs sharply alongside it. But then it hits a peak, right in the middle, a turning point. After a country crosses that specific threshold of wealth, the curve actually slides back down, meaning the environment starts improving even as the country continues to get richer. Wild, right? So, how does that actually happen? Let's look at Section 3, Drivers of the Curve. Economists break this journey down into three distinct channels. First, as we start out, we hit the scale effect. This is where just a larger scale of economic activity directly creates massive waste. But then, as the economy matures, we hit the composition effect. The actual structure of the economy shifts from heavy, dirty industry to a more service-based economy. And finally, we reach the technique effect, where those older, dirty technologies are swapped out for much cleaner ones. So what actually builds that downward slope? Well, as economies expand, they can finally afford to transition from, say, coal to renewables. At the same time, governments start stepping in with effective policies and emission limits. But honestly, perhaps the biggest driver is that as people increase their income, they simply start demanding a healthier environment. Wealthier populations put pressure on businesses to offer eco-friendly products, meaning everyday consumer preference actively drives massive macroeconomic change. Let's ground this with Section 4, Real-World Evidence. To see how this plays out in reality, a comprehensive study analyzed 261 cities in China between 2004 and 2013. Now, during this period, China experienced absolutely explosive economic growth. And exactly as the EKC predicts, this rapid industrialization initially worsened the environment. They were climbing the left side of that U-shape, suffering severe ecological strain as their metropolitan areas expanded. But here is the fascinating turning point researchers discovered. For most general pollutants, the relationship between economic growth and environmental impact actually reversed once per capita income hit about $8,000. At that exact threshold, thanks to cleaner tech and new regulations taking hold, the environment actually started improving. However, we definitely can't ignore the extremes. For severe pollutants like sulfur dioxide, the study found that the turning point requires a massive, almost unthinkable income threshold of over $100,000 per capita. And that's a crucial takeaway. The curve isn't uniform. Some pollutants are relatively easy to clean up as a society gets richer, while others require astronomical levels of wealth before they even begin to decline. This brings us to Section 5, Criticisms and Complexities. So, is this neat little economic curve just too good to be true? Well, one of the most glaring criticisms is that the curve might create a highly biased reading of the world. Critics argue that developed nations often look like they're gracefully sliding down the improving side of the curve simply because they've outsourced all their dirty production and resource extraction to developing nations. If rich countries are just shifting their pollution across borders, total global degradation isn't actually decreasing at all, is it? Furthermore, the limitations of the EKC become pretty stark when you look at the details. We found that the curve really only works for specific, localized pollutants. It also completely ignores time lags. The damage done today might take decades to show any improvements. And most worryingly, the basic EKC model treats pollution as a harmless, temporary flow, rather than acknowledging that some ecological destruction is simply irreversible. You can't just buy back an extinct species or a totally destroyed ecosystem, no matter how high per capita income gets. This is exactly why modern economic literature has heavily criticized older static models of the EKC, shifting instead to dynamic models. See, static models wrongly assumed the U-curve just happens automatically, and they treated pollution like a harmless flow. Dynamic models reflect reality much better. They treat environmental quality as a finite stock. As the economy grows, that stock degrades unless direct, active investments are made to replenish it. The improvement isn't magic. It requires intentional, overlapping generational effort and serious abatement investment. As the research clearly warns us, and I quote, "Not all relationships between economic expansion and environmental degradation take the shape of an inverted U. We cannot simply rely on economic growth alone to automatically save the planet. If a society just grows its wealth but never invests in those technique or composition effects, if they never implement strict environmental policies, the curve will just keep going up, resulting in catastrophic pollution." Which leaves us with a final, absolutely critical question. Will this theory actually hold up against our ultimate test of global climate change? High-income countries still heavily contribute to global greenhouse gases, proving that not all pollutants easily bend to the will of wealth. So, are we capable of actively driving ourselves over the peak of the curve through intentional policy and technology? Or are we simply running out of time on the upward slope? It's a question our generation will ultimately have to answer.